This section is 6.5b, solving absolute value inequalities. Yesterday we talked about solving absolute value equalities, and now we're going to be dealing with the inequalities and graphing those inequalities as well. So let's talk about two scenarios here. If we have the absolute value of x is greater than or equal to 1 versus the absolute value of x is less than 1, okay? What is the difference between how these will graph? So here's my number line. Here's 0. Here's 1. Here's negative 1. Okay, we can do the same number line here. Okay, what numbers, when we take the absolute value of them, will it be greater than or equal to 1? Okay. So 1, if we take the absolute value of 1, will it be greater than or equal to 1? Yes, so 1 will work. So we're going to put a closed circle on 1 because it will work. Okay. What else will work? 2 will work. And anything above 1 would work. Okay? What else? Will 0 work? The absolute value of 0 is greater than or equal to 1. No, that's not going to work. We'll put an X through it. Okay. How about 1/2? Will 1/2 work? The absolute value of 1/2 would be 1/2. Is a half greater than 1? No, half won't work. Okay. What about 0.99999? If we take the absolute value of that, we get the same number. Is that greater than or equal to 1? No. Okay? So none of these numbers in here will work. These will work. Are we done though? No, we've got to try the negatives also. So let's say we do the absolute value of negative 1/2 right here. The absolute value of negative 1/2 would be 1/2. Is 1/2 greater than or equal to 1? No, 1/2's out. All of these fractions will be out. Let's try negative 1. The absolute value of negative 1 is 1. Is 1 greater than or equal to 1? Yes, negative 1 will work. What else will also work? Negative 2, any of these numbers below negative 1. So what do we have left? If we get rid of all these x's that don't work, then we're left with this graph. A closed circle at 1 and everything to the right of it. A closed circle at negative 1 and everything to the left of it. Okay? And this is greater than or equal to. Okay? What happens if it's less than 1? Okay, the absolute value of x is less than 1. What numbers will work? 0 works. The absolute value of 0 is less than 1 because we get 0 is less than 1. Okay? Will 1 work? The absolute value of 1 is not less than 1. So 1 is not going to work. Okay? Let's just leave that blank for now. What about 1/2? The absolute value of 1/2 would be 1/2. Is that less than 1? Yes, that'll work. Okay, 1/4. Okay, keep working. All of these will work until you get to 1. What about 0.9999999999999? Okay, the absolute value of that will still be 0.9999999, which is still less than 1. So these are going to work all the way up until you get to 1. So what we're going to do is put an open circle on 1 to show it goes all the way up, but it stops at 1. 1 is not included. Oh, so we can also check the negatives. Okay? The absolute value of negative 1/2 is still going to be 1, which is not less than 1. So negative 1 is still not going to work. Negative 2 will not work. Okay? But in here, the absolute value of negative 1/2 would be 1/2, and that is less than 1. So these will work. And any of these numbers. So it's going to look the same as this, mirrored to the other side. Negative 1 won't work, but all the numbers up to negative 1, or I should say down to negative 1, will work. Okay, so this is a greater than. This is a less than. And the only difference with the equal to or the non-equal to is that these are closed circles and these are open circles. But I want you to focus more on the pattern. In a greater than, they're going in the opposite direction. Okay? In a less than, they are everything between. Okay? Now, which ones? We have talked about compound inequalities. We have two types of compound inequalities. We have an and we have an or. So which one of these looks more like an and? This one. This one looks more like an and because let me remind you of what's happening. If x is less than 1, we have this possibility. But we also, if we split this into two inequalities, what we end up is with the second inequality. And I'll explain this a little bit more. And then we find where they overlap, which is going to be this place in between. Okay? A less than is always going to be an and. A greater than, think of it as greater than, is always going to be an or. And remember, if we were to graph these, we graph one above here and one here, and we bring them both down to the graph. Reminds us that this, or it brings us back to the graphs that we did before that were ors. So now let's go through a whole problem so this makes a little more sense. But we can also write this on your Cornell note sheet. Greater than. And if you say it in your head, greater is always an or problem. Less than is always an and compound inequality. So all the skills that we learned in section 6.4, compound inequalities, you will be utilizing in this section and then adding this one skill. So if you were good at section 6.4, if you can remember the difference between these two, then this section will be a piece of cake for you. No problems at all. So let's look at a full example. Number 1, the absolute value of x minus 4 is less than 3. So what we're doing is combining what we learned in absolute value equalities and combining that with compound inequalities. And those two ideas we're using together and doing the problems that we're working on today. So if you remember absolute value equalities, yesterday's lesson or the previous lesson, we have to isolate the absolute value and then split it into two. Now there's some similarities and some differences. The first one, remember when you split it, the absolute value bars drop out. So remember to do that. We get x minus 4. The first one actually was equal to the positive version. And if you look at it more closely on the last lesson, the left side was always exactly the same as the original. So the left side will still be the same as the original. The inequality you leave the same. Now on the right side, we're left with x minus 4, but we are basically multiplying this by -1 to get the -3 on the right side. And when we multiply that by -1, that requires that we flip this inequality sign to greater than. So on the left side, all we do is drop the absolute value bars. On the right side, we have to do two things. We're doing the negative version of this constant, and we are also flipping the inequality symbol. So if it was less than, now it's greater than. So there's two different things that you have to do on the right side. You have to flip, and you have to make it negative. Flip the sign, make this negative. Okay? This one stays exactly the same. That is the most difficult piece here, but the other thing you want to make sure you always include, if this is less than is always an and. So from the very beginning, when you're splitting it, you should differentiate between the and the or and make sure you write that down. Now we solve these and graph these. So we add 4 to both sides. We get x is less than 7. And add 4 here. We get x is greater than 1. Now when we go to graph these, we've got our number line. Remember we need 0 and 1 and 7. So we're going to make two graphs above, just like section 6.4. X is less than 7. That would be an open circle and everything less than 7. X is greater than 1. That would be an open circle and everything greater than 1. And tells us that we're using the keyword overlap. So we want to find the place where these two overlap and bring that down to the final number line. Okay. And then we can also add our set notation and our interval notation here that we did in section 6.4. So set notation would be x such that 1 is less than x, which is less than 7. Let's talk about that. So x is somewhere between these two numbers. So we put x between these two numbers. This is always going to be less than if you write from smallest to largest. And the open circle means that we use just less than, and no equal sign underneath. Now for your interval notation, we've got a soft bracket on 1 because the shading starts at 1, and a soft bracket on 7 because the shading ends at 7. Oops, slide that up a little. Okay, so that's what we're working on here. This is an example. We're going through all the same steps. So the splitting is the previous section, 6.5a, learning how to split it. Solving it is 6.4, graphing it 6.4, set notation, interval notation, all 6.4. So the only part that is really new to 6.4 is this section right here, how to split it and what you need to do to it. So let's practice again some more. Example 2. The absolute value of x plus 1 is greater than or equal to 2. Why don't you try this one on your own and see how you did here. All right, so we're going to split this first. We get x plus 1 stays exactly the same. It's greater than or equal to 2. The left side stays exactly the same. On the right side, you have to do two things. X plus 1, flip the inequality sign, is less than or equal to, change the sign to negative, okay? So because we're technically multiplying this by -1 to get this, then when we're multiplying by a negative, this inequality sign has to flip to less than. Go ahead and solve. If you didn't try this on your own, here's a place where you could finish and solve this on your own. Now this is a greater than, so you should put an or in here. Okay? Go ahead and finish that if you haven't already. So we need to solve each of these. So we subtract 1 from both sides. We get x is greater than or equal to 1. Or, subtract 1, x is less than or equal to -3. Make your number line. We've got a -3, a 0, and a +1. X is greater than or equal to 1. Greater than or equal to 1. Less than or equal to -3. Or tells us the keyword's going to be both. So we bring both of these down to our final graph. Like that. Now, set notation and interval notation. If it's an or and there's two shaded regions, then you need one set notation, but you need two intervals. So x such that x is less than or equal to -3 or greater than or equal to 1. Now remember, you need a subject here and a subject here. There needs to be an x in each of these inequalities, so you can't leave the x out. Okay. Now interval notation, some people think this one is easier than this one, but the shaded region begins at the left arrow, so that means it starts at -infinity, and it goes to the -3. Now because it's a closed circle, that means we're using a hard bracket. Then you need a union to connect the two together. And then the next shaded region starts at 1, and again we're going to use a hard bracket because it's a solid circle. It's including 1. And it ends at the right arrow, so that means it ends at +infinity. Remember, the infinities always get soft brackets, whether it's a -infinity or a +infinity. Open circles also get soft brackets. Closed circles are the only things that ever get hard brackets. Okay. All right, now the last two are simply more of that, except a little more challenging solving the inequality, the absolute value, or isolating the absolute value. So I do believe you could try these last two on your own without any help from me. See if you can fit them on your page. I'm going to flip to the back to make sure we don't run out. But number 3, 6 times the absolute value of y plus 1 is greater than 60. And number 4, the absolute value of 7y plus 14 minus 5 is less than or equal to 30. Okay? Now, the only difference between these and the previous two is that you have to isolate the absolute value first. I would really, truly like you to try these on your own and see how you did on these two. Please push pause here and try these before you move on. So in number 3, the first thing we need to do is isolate the absolute value by dividing both sides by 6. The absolute value of y plus 1, because the 6's will cancel, is greater than 10. Once you've isolated the absolute value, then we split these two. Y plus 1 is greater than 10. This one stays exactly the same. This one you do two things. Y plus 1, flip the inequality symbol so it's less than, change this sign so it's negative 10. And we finish solving and graphing and shading and all that good stuff. So subtract 1 and we get y is greater than 9. Subtract 1 and we get y is less than negative 11. Make your number line. Negative 11, 0, 9. Doesn't matter how far these are spaced out, so don't worry about that. As long as negative 11 is on the left of 0 and 9 is on the right. So y is greater than 0. What did I forget? We need a conjunction. Greater means this should be an or. So y is greater than 9. That's an open circle and everything to the right. Y is less than negative 11. Open circle and everything to the left. Less than left. And remember, this always points in the direction that you shade. Or means we bring them both down. So bring them both down to your final graph, and we're going to do our set and interval notation. Y such that, and our set and interval, or set notation is basically this right here, but some people like to put it in the order that you see it. So this one first, y is less than negative 11, or y is greater than 9. Or you can read it straight off the graph. Either it's less than negative 11 or it's greater than 9. But it does come straight from this line here. Interval, you need two intervals with a union between. One for this shaded region, one for this shaded region. So this one begins at negative infinity and goes to negative 11. Now it's an open circle, which means it's a soft bracket. And again here, it begins at 9 with a soft bracket because it's an open circle, and it ends at infinity. So all soft brackets here, or curved, rounded, whatever. If you did not try this one on your own, please try this one on your own before you peek. No cheating. All right, isolate the absolute value by adding 5 to both sides. 7y plus 14 is still an absolute value, less than or equal to 35. Once you get the absolute value isolated, then you split it. Do not split it before you isolate it. You will get one correct answer and one wrong answer every single time. Isolate the absolute value first, now split it. 7y plus 14 is less than or equal to 35. This one stays exactly the same. Nothing changes. This one, 7y plus 14, is greater than or equal to, so you flip that sign, negative 35. Okay. Now you solve it. So one misconception with the absolute value is that you're flipping the sign in here. You actually aren't going to touch this at all. 7y plus 14, 7y plus 14, the same both times. The sign will be positive here, negative here, And in this case, because it's an inequality, this inequality symbol will flip. So nothing changes here, just drop the absolute value bars. Here you flip the sign, make it negative. Now we solve. Subtract 14 because we always undo addition and subtraction first. 35 minus 14 gives us 21. Then divide both sides by 7 and we get y is less than or equal to 3. Same steps over here, subtract 14. And we get 7y is greater than or equal to negative 49. Divide by 7 and we get y is greater than or equal to negative 7. Okay. Now I forgot to do the conjunction, but this is less than. You have to go back to the original. Make sure you don't go back to these because you get both of them then here. But the original is less than, which makes it an and. So that means we're finding where the two overlap. So here's my number line. We've got negative 7, 0, positive 3. Y is less than or equal to 3. 3 and everything less than. Y is greater than or equal to negative 7. Oops. And we want to find where they overlap, which is right here. So our graph on our number line should look like this. Okay. And then we have to finish it up with our set and interval notation. So we've got set notation, y such that, now y is the shaded region between these two numbers. So we write the numbers on either end and we put y in between. It's always, always, always going to be less than if you put them in order from smallest to largest. And when it's closed in circle, that means you need an equal sign under it as well. Okay? Negative 7 is less than or equal to y, which is less than or equal to 3. The interval begins at negative 7. It's a hard bracket because it's a closed circle, and it ends at 3. And again, it's a hard bracket because it's a closed circle. All right, how did you do on those? Let me know tomorrow if you understood those, or if you needed a little more practice on those. You can remember you can always rewind and go back and check your work again and review anything that I've said.